So this is the tenant level view for tenant 1 from SD-WAN point of view. So you can see various statistics for the tenant. So totally there are 8 sites and there's 1 site with low availability. So on clicking, you will see the site which has low availability. Then there are also statistics about sites which don't have data plane, which has seen some data plane downtime, sites with critical and major alarms, sites with disconnects, sites with violations, etc. You can also see what are the top sites of the tenant by bandwidth, by volume, etc. So you can change the metrics type here. You can see top WAN links of this site, of this particular tenant. Then you can also see the sites of the tenant in the map. The color here represents the availability of the site. So on clicking, you can see the site level details. You can look at the traffic view. So here, this particular site is talking to a site, remote site shown here, that's branch 4. You can see the connectivity view. You can see alarms. Like if you drill on this particular site, you can see the top alarms of each of the site. You can see threat events if they're present. In this example, it's not present. For that, you need to have a security feature enabled and some threats active on those devices. And finally, heat map, which shows which sites have most traffic. So in this example, most of the traffic is originated from San Francisco site. So you can see it shown in red. Most of the time, we need to look at specific details of a site. So for that, we can filter on that site. So in this example, if I go to SD-WAN branch 1, you can see the site level view. So this shows the SD-WAN usage of branch 1 by bandwidth. You can do it based on volume, TX, RX, etc. There are various controls here which can be used to change the chart type, to change the resolution of the chart, show trend lines, and change the metrics type, etc. There's also the overall summary use for the time for the last day in this example. This is a summary of volume of traffic sent and received, bandwidth, etc. So the next tab, availability, is a very important report which tells you whether the device is reachable from the controller point of view. So it tells you whether there was any connectivity loss to the controller. So in this example, at certain time today, there was a down event seen, down and degraded event seen. So this might be due to the site restarting. So if you go to the next report, that is the service uptime, it helps us know that. So it shows that the site rebooted 10 hours back. So that implies that the downtime was maybe because of the site got rebooted. So the next chart shows the data plane connectivity over time. So sometimes the device may be connected to the controller using one link and to the hub and other branches using other links. So reachability towards the controller does not mean that the branch is all healthy. Sometimes it may lose the connectivity to hubs and other locations, in which case no actual traffic can flow. So it is important to know if there is any data plane connectivity issue. So this chart shows that. We also have some high-level metrics on the percentage of paths that are down from this branch, number of remote site down, etc. So this chart now here shows the link availability of the branch. So there are 3 WAN links here, WAN 1, WAN 2, and WAN 3. So WAN 1 and WAN 2 are mostly up, but there was a time at around 12 that all the branches saw downtime, and this is because the branch itself got rebooted. Otherwise, overall, the branches, the links has been up from WAN 2 and WAN 3 point of view, and WAN 1 has been up only since 10 o'clock. So this helps us know how the WAN links are performing over time. Now, there are also some status logs which the controller publishes saying if the branch got disconnected or not. So this is during the time when the branch got rebooted, there was a disconnect information sent to the analytics. So this helps troubleshoot when the branch exactly went down from the controller point of view. Now, the next tab shows the WAN link utilization. WAN links also called as access circuits here. So there are 3 WAN links, and this shows the overall utilization of the WAN link by bandwidth, by volume, TX, RX, etc. You can also see the summary here. Now, if you want to see the breakdown of how much of traffic is SD-WAN and how much is DIA, you can see it over here. So if it is always branch-to-branch traffic, they are called SD-WAN traffic. And if there is a local breakout, that is the traffic is sent from the branch to the internet directly, it is called as the DIA traffic. And in this example, I do not have DIA traffic from this branch. So there's only branch-to-branch traffic. And if you want to see what exact traffic is going at any point of time, you can zoom into that particular time range and you can drill on it, and it shows what traffic went at that time. So this shows what are the top applications and the users of the applications which consumed the bandwidth at that moment of time. So all the detailed information can be seen over here. The next important report is the users. So from the branch point of view, it's important to know who is consuming the WAN bandwidth. So these are the top users consuming the WAN bandwidth. Now, if the username is known through some Active Directory or Kerberos integration, username will be shown here instead of the IP address. So in this example, I do not have that integration, so it's only the IP addresses that are shown. So this shows the usage of the various users per WAN link. Now, on drill down of any of the users, you can see what are the top applications used by that IP or the user, which destination those traffic was destined to, and the overall usage over time. Now, same information can be, similar information can be seen from the application point of view. What are the top applications of this branch? Now, you can categorize the application as SaaS app, video, voice, etc. So this shows the breakdown of the various application type and also whether they're business or non-business. So every application is associated with a tag, which helps us know whether it's business or non-business. And if you decide that some of the applications are not really non-business, you can go and change the tag in the director. You can also see the application usage over time per WAN link. And here, as you can see, initially it was taking using WAN 2 and WAN 3, and later it just is sent on WAN 3 because WAN 2 and WAN 1 had some traffic loss. So most of the traffic has been sent on WAN 3 here. Now, this shows all the applications and the metrics associated with it. So we can now drill down to any specific application, let's say Netflix here. Now, this shows the utilization of Netflix by various WAN links. So most of the traffic initially was sent on WAN 2, but later it started getting sent on WAN 3. Now, these are the top users of application Netflix here. Now, if you want to know the overall usage metrics of Netflix traffic per user, it shows here. So it also shows whether the traffic was SD-WAN or DIA. So this Netflix traffic from the branch 1 was sent on the SD-WAN overlay towards the Netflix servers. And it used traffic class of FC2. And these are all the various session, volume, and bandwidth metrics for the traffic. Now, if application performance monitoring is enabled for the application, we do passive monitoring of the traffic, we collect all these various TCP and HTTP metrics, such as network response time, server response time, application response time, retransmissions, etc., and then compute a rank. So this rank helps us determine whether the user experience was good, bad, or degraded. So lower the number, better the experience is. Now, if we enable detailed flow log for the traffic, then you can see all those logs over here. So in this example, we have enabled traffic monitoring logs. So because of that, per flow logs can be seen. So for each of the flow, you can see the 5-tuple information, like the source address, destination address, source port, destination port, protocol, and some packet and byte count. But mainly, it also provides information about how the traffic was sent on the SD-WAN overlay. So it shows that the traffic originated from this local site SD-WAN branch 1 was sent to remote site SD-WAN branch 2 because the server is sitting behind branch 2, and it was sent on the forward direction on WAN 3 path, and the reverse direction also the traffic came back on the WAN 3 path from branch 2. Now, sometimes the traffic might go through another branch, in which case it will show you that information too here. So these are the other information associated with that traffic, like the forwarding class, zones, and packet byte count, duration of the session, etc. Now, next thing that we will see is the SD-WAN rules. So in case of SD-WAN, there is policies or rules created for different traffic types. So in this example, we have a rule for business critical traffic, all applications matching as business critical traffic, which are business critical, are mapped to this rule. So this shows the utilization of that rule, how much traffic matched that rule. It shows the utilization over time, and it also shows which remote site this traffic is sent to. So from branch 1, most of the business critical traffic was sent to branch 2. So on a drill down of this, we will get to see how the traffic which path the traffic took from branch 1 to branch 2 for the last day. So in this example, it took WAN 2 path in the beginning, but over time there was some failures, because of which it started taking WAN 3 path. So as you can see, initially WAN 2 path was seen, but there were some SLA violations around this time, around 10 or 11 o'clock, and due to which the traffic started flowing on the WAN 3 path. And the details of the SLA violations can be seen over here in the form of alarms. So it gives complete information about the path which had the violation. It shows the metrics which was violated. And so in this example, as you can see, there's high PDU loss ratio, because of which the path could have switched from the WAN 2 to WAN 3. So looking at this, complete information can be derived as to why the traffic steered from one part to the other. Now, next tab shows the SLA metrics, and this is a very useful information from operation point of view. So in a typical deployments, there are WAN links from different service providers, and sometimes some of the WAN links may have poor performance. So to know if there are some underlay issues, SLA metrics can be used. So we run periodic probes between pair of branches on every path that are active. So those metrics are used for traffic steering decision as well as for visibility in analytics. So these are the overall metrics for the paths. So between branch 1, between branch 1 and branch 2, there are many paths. So here you can see the delay variation, the forward loss, reverse loss, and the PDU loss related metrics. So if you want to drill down onto any of these, say let's drill down from branch 1 to branch 2 on WAN 1 path. So you can see that there was some high delay around this time. There's no PDU loss, but there was some reverse loss over time. And most of the time, such loss are attributed to the underlay issues. And so then you could contact the underlay service provider to rectify the issue. So this SLA metrics is based on active monitoring of the various paths. So based on the SLA metrics, we figure out if there is any failure on the path. So if we lose 3 back-to-back PDUs by default, then we mark the path down, and this is something, some information used by the traffic steering module to switch from one part to the other. So summary of that SLA data part down events can be seen over here. So it shows that from branch 1 to all these different branches, there were so many flaps. And also when there's no flap and there's some packet loss or high delay, there's SLA violation detector, and that can be seen over here per SD-WAN rule. So all those alarms corresponding to it, if it's enabled, can be seen over here. Next, tab is for VRF. So there could be many LAN side VRFs configured to carry different types of traffic, for example, guest Wi-Fi or HR or finance, etc. Now, if you want to see which LAN side VRF is consuming the WAN bandwidth, you can see this report. So in this example, we have only one VRF, tenant 1 LAN VRF, and it is using all the 3 WAN links. And this is whether it is going as SD-WAN or DIA can also be seen over here. The next tab is QoS. So for this branch, this is a multi-tenant branch. So tenant 1 is one of the child tenants. So since it's a multi-tenant branch, the quality of service is configured on the interface, which is shared across the branches. So the information related to that quality of service the quality of service metrics can be seen from the provider tenant context. So if I go to provider org and then drill down to this branch and look at and go to the QoS tab, you can see all the traffic that was sent on this WAN links. We do egress shaping. So it shows per WAN link, the traffic utilization, the bandwidth utilized per forwarding class. You can choose, you can see it for all the forwarding classes together or per forwarding class. So if you want to see for best effort or expedited forwarding or any of those FCs, up to 16 forwarding classes are supported. If there is any drops, you can see it over here. In this example, there are no drops. If there were drops per forwarding class and per WAN link, you can see here in these charts. Now, let me go back to the tenant level view. So when we did in the SD-WAN path monitoring using SLA metrics, the monitoring was done between 2 Versa devices. So we were able to collect all the latency delay, latency jitter, loss metrics, etc. But sometimes the destination may not be running Versa device or Versa software or SD-WAN device. It could be destination server. So in such cases, we need to do passive monitoring to know whether the application experience is good, bad, or degraded. So if passive monitoring is configured on the device for a particular application or for business critical applications, we collect various TCP and HTTP metrics, and we come up with we derive the rank as explained earlier briefly. So which we call as a Versa link rank or Versa app rank. And what this provides you is an indication of how the application was performing for this specified interval. So in this example, if I drill on LinkedIn, you can see that the application experience towards this destination was poor mostly. And These are the sources which saw the poor application rank, and most of the traffic was sent through the branch 2 from branch 1. So if you look into the detailed metrics here, you can see that the traffic was mostly using WAN 2, and because of which had very high loss, and because of which there was there's poor rank. And that's we can also see the retransmissions, very high retransmissions, which contributed to the rank being bad. These are various metrics that are used to compute the rank. That is the network response time, server response time, retransmissions, SYN-ACK time, SYN-ACK time, etc. Now I'll switch the portal to another portal which has the real traffic, the real corporate traffic flowing through it. So as you can see, this is an example where there is live traffic, live user traffic going through the branch, and any drill down here again will show similar information as I showed earlier, which shows which destination had poor rank. In this example, this particular destination has poor rank, so indicating that it's mostly the destination issue and not the network or the user level issue. So these are the various information metrics that was retrieved for this traffic. That is the network response time, the application response time, the server response time, and all the other metrics. Now, if we can also do active monitoring by sending probes to a destination server using FQDN name or IP address. So it could be an application server within your data center or in the cloud, and you can these probes will help collect the latency, loss, jitter, etc. So the probes could be based on ICMP, HTTP, wget, etc. So this helps you know the last leg health of the network. Now, for voice and video traffic, we also we analyze the RTCP traffic. We extract the codec and the MOS values, and then see what is the MOS scores for various sessions. So in this example, we can see that for various codecs, these were the average MOS scores and the number of sessions which had poor MOS values. So 1 to 2 is considered bad, and 4 to 5 is considered good. So most of the traffic had a good MOS value, that is a mean opinion score value. But some traffic, some codec had poor experience. So this helps us know if the voice and video traffic had poor experience on the SD-WAN network or not. Now that was mainly the site level view. Now let's go back to the other charts and reports that we have. So from the, if you go to the sites page, you can see the overall usage of all the sites belonging to the tenant, the top sites by bandwidth or by any other metric that you want to choose. You can see the overall site availability. In this example, the branch 5 is down, so it shows 0 availability. And branch 1 had some downtime, and that's why it shows less than 100%. It also shows the link availability, which is per site, per WAN link, what is the availability over time. So as you can see, branch 1, all the WAN links had downtime at the same time, which indicates something was wrong with the particular site. Then you can also see the heat map, which shows all the sites, and the color indicates the availability, and the size of the block indicates how much traffic is flowing on it. And so this chart helps us see all the sites in one view. instead of having to drill down to a specific site. Now, next, coming to the paths. So in most of the SD-WAN deployments, the traffic is going from one branch to another branch, and you want to know how the traffic is performing, which path it is taking, etc. So if, for example, I'm troubleshooting branch 1, and my traffic is mostly going through branch 2 to destination, so I can choose branch 1 and branch 2 here, local site and remote site, and I can look at all the metrics in one place. So if I want to see which path the traffic took, so initially it took WAN 2 path, but then it's at some point around 10 o'clock, it started using WAN 1 path because there was high loss seen on the WAN 2 path. So around that same time, you can see that there was loss seen on the WAN 2 path, and that's the reason why the traffic switched to the WAN 1 path. So seeing seeing this report, you can easily know how the traffic is flowing, which path it is taking, and why it is taking that path. So overall usage information can also be seen over here. We can also see between the pair of branches, the SLA metrics, as we saw earlier under the site level view, and other information. So this is one of the most important report here, the quality of experience report here. Between the two branches, there are various paths, and individually these paths have poor performance, except for this WAN 3 link. But the overall traffic between these two branches was not degraded, it was in a good state because of various SD-WAN traffic steering policies, FEC and replication kind of features enabled. So this helps know how the customers have benefited from using SD-WAN.